Hi everybody, so here is an example for tutorial 3. Before I actually show you examples, I'm going to talk a little bit about dot product. So if you see here, we have two vectors, vector A, this vector A here, it has a two component, this AY and then AX. And we have another vector, vector B, that's towards x-axis, okay? And we have already represent each x-axis and y-axis as, with unit vector I hat and j hat. If we write these vectors in the component form, we can write this as here, vector A equal to ax I hat plus ay j hat. And we do the same thing for vector B, but for this vector, we don't have any component towards y-axis, so we just have bxi hat plus 0j hat. I just wrote this only to make it easy for later on, but you don't really have to write this part. So in general, there is a way to find the dot product between these two vectors. So dot product. So if we again find the dot product between the vector A and B, then we can write it in this form. So write the component of vector, write this vector in component form, just like here. Take a dot product with the second vector here. So if we do the dot product, well, how do we do the dot product? So it's similar to ordinary multiplication, but one important thing to see here is that we have these unit vectors, so that makes multiplication or the dot product different. Okay, so let's start with this. Let's use let's multiply this with this part to this entire vector here. Okay, so ax bx here, and then I hat, and the operator dot comes here in between the another unit vector I hat here. So I dot I hat here. Okay, so this operator dot has to come between the vector, not anywhere in the component. Okay, that's the important part. The second part is we just now repeat. So plus this plus sign here, and then we are gonna again multiply this guy ax I hat with by j hat. So when we do that, we get ax here, by here, and then I hat, and then this dot operator here, and then this j hat over here. Okay, plus this plus sign here, and then we are going to do the same thing for this second one here, and then just take a dot product of this guy with this whole thing, and we end up with this line. But for vector dot product, when we take a dot product of a unit vector here, I hat with I hat, that must be equal to j hat dot j hat, and the value is actually constant, which is 1. But if we take a dot product of I hat with j hat, or dot product of j hat with I hat, that gives us 0. So anything here that has I hat dot I hat will give us 1. Anything that has dot product between two unit vectors like I hat dot j hat, that becomes 0. So we can ignore this part also goes to 0. So we are left with only this part, and then this part here, that's what we are writing here. So a dot b is just ax bx plus ay by. Okay, so that is in general the dot product is written in this form. This is called the component form. If we use this for our diagram above right here, for this case, then we will get a dot b equal to, again, the vector a, components of vector a dot components of vector b, and then since the vector b has only component towards I hat, so j hat doesn't matter to us, so the only thing that survives is just the the ax I hat dot bxi hat, and then that gives us this. So we are left with a dot b equal to ax bx. Okay, this equation 2 can be expressed in another way. So this is alternative method. Let's say ax equal to a cos theta, right? So if you go back to the diagram here, this vector a, if it's making angle theta, then we can write, ax as a cos theta. So, but then b is really only towards the I hat direction, so b cos of 0 degree, right? The vector b is making 0 degree angle with x-axis. So, oops, sorry about that. So bx is just b cos 0. Cos 0 is 1, so we are left with just b. So therefore a dot b is equal to a cos theta b, and then if we rearrange this, we get a dot b equal to a b cos theta. This part here, this a cos theta or a cos theta here, is called the projection of vector a onto vector b. So what does that really mean in the diagram? Projection of this vector onto vector b. It means really how much of vector A is tilted towards really vector B. Okay. So imagine, right, if you had theta, this angle was smaller, let's say like 30 degree. And if you had, and then let's say we increase that angle 30 degree all the way to like, let's say 80 degree. Then obviously this vector, if we make it all the way to 80 degree, then somewhere around here, of course the amount of vector A towards B would be less, right? So if we have a higher angle of this theta is higher, then the A component of A towards I hat is going to be smaller. All right, now we are going to see examples. So number 2 from the tutorial 3. Here is a diagram. You are given vector here, this in blue color here, which has a magnitude 20 degree, and there is another vector 20 degree. Let's call this as vector A, let's call this as vector B. You are also given this angle 165 degree that vector A makes with x-axis, and then you are also given this angle 45 degree that this vector B makes with part of vector A. Okay, so it's like that. So there are few ways to find dot products. So let's use this method here. So what we are going to do is we are going to do this, move this, so leave this vector which is at origin here, which starts at origin, leave it as it is, and then move the other vector here, this guy, to the origin. Okay, so just move really means translate this like this. So whatever is like this here, just bring that and then put it there. Okay, make sure the direction of this vector, this angle doesn't change. That is very important. I also have a dash line here. This is really to this line is drawn so that this line is parallel to this x-axis. That way I can find this part of angle, this amount of angle here. So here in this case, let's look at before we actually go in detail. This is 165, so 180 minus 165, this angle must be 15 degree. If this is 15 degree, this part, the little part of this angle here, should be 15 degree as well, because it's going to be alternate angle, and the whole 45 degree minus 15 should give us 30 degree. This part is going to be 30 degree. So when we move this vector over here, that should make angle 30 degree here. Okay. All right, so I was talking about the steps, right? So once you move this vector here, you find the angle, and after you find the angle between these two vectors. So once you move this vector over, you want to find this angle. Okay, so the angle between these two vectors, when both of them are lying at the same origin. Okay, and then you can use the angle form for dot product. So let's see. So I'm just gonna say a few things here, label a few things. So theta 1 has 165 degree, theta 2 has 45 degree, just for easy calculation, and magnitude of A is given, magnitude of B is given, which both are 20. So as I said before, when B is moved to origin, the direction remains same. So from figure, angle theta, let us say, made by vector B with vector A is 135 degree. Just like how I said, I also have a little diagram here in case you want to refer it back. So now we can find the dot product between these two vectors. Vector A dot B is really AB cos theta. A is given, which is 20, B is given, which is 20, and cos. And then the theta is, we found, that's 135. If you put this in a calculator, you end up with minus 283. Okay. Okay, so another way to do a dot product. So I have shown here number 5a. So here we are going to use the component form for dot product. So two vectors are given again here in a component form. A equal to minus 3x hat minus 4y hat, B equal to 11x hat minus 3y hat. So here we use component form of dot product. Therefore A dot B is equal to what? Ax x hat, x hat is same as I hat, right? Plus ay y hat dot bx x hat plus by y hat. Now when we substitute the value of these, ax, ay, bx, by from this given scenario, then we end up with this equation here, this part here, and then now we are just going to take the dot product. Okay, like the way we explained at the beginning. So dot product of this part must be dotted with this whole thing, but we know anything that comes with the x hat and what x hat dot y hat will not survive. The only thing that's going to survive is just the dot product between x hat and x hat. Okay, so this guy here, minus 3 times 11, and then x hat here, this dot product comes right here, dot, and then x hat again, x hat here. This is one part, plus for this guy here we are going to do now 4, that's minus 4 here, right? Minus 4, and then since this part will not survive, so we have here minus 3, so that comes here, and then we do y dot y hat, which is written here. Now since x dot x hat equal to y dot y hat equal to 1, so we end up with what? Minus 3 times 11 is minus 33, plus minus 4 times minus 3 is plus 12, and then that gives us minus 21 here. Alright, that's about it.